Imagine floating far beyond Earth, beyond our solar system, beyond the Milky Way, beyond every galaxy you've ever seen. As you travel farther and farther into the cosmos, something surprising begins to emerge. The universe, which appears random and chaotic on small scales, starts revealing a hidden pattern. Galaxies gather into clusters. Clusters connect into enormous filaments, and these filaments stretch across distances so vast that they challenge our understanding of reality itself. But among these colossal structures, astronomers have discovered something even more astonishing: gigantic cosmic walls, structures so immense that they seem almost impossible to exist. Tonight, we're exploring the walls of the universe, the largest known structures in existence, and the mystery of why they are there at all. When most people imagine the universe, they picture galaxies scattered through space, like islands in an endless ocean. And for a long time, that's exactly what scientists thought. But as our telescopes improved and we mapped larger regions of the cosmos, a different picture began to emerge. Galaxies are not evenly distributed. Instead, they form a vast network known as the cosmic web. Imagine a three-dimensional spider web stretching across the universe. Along its strands are billions of galaxies. Between those strands are enormous empty regions called cosmic voids, some hundreds of millions of light years across. This cosmic web is already difficult to comprehend. The Milky Way contains hundreds of billions of stars. Our galaxy is part of a group of galaxies known as the local group. The local group belongs to an even larger collection called a galaxy cluster. That cluster is part of a supercluster, and even superclusters are merely tiny pieces of a much larger cosmic structure. Every time astronomers zoom out, they discover that the universe is connected on scales larger than anyone expected. Then, in the late 20th century, scientists uncovered something extraordinary. They found immense formations of galaxies arranged in long, wall-like structures spanning hundreds of millions of light years. One of the first major discoveries was the Great Wall, stretching roughly 500 million light years in length. It was unlike anything astronomers had ever seen. Suddenly, the universe appeared far more organized than previously imagined. What looked like randomness was actually part of a grand, cosmic architecture. But the Great Wall was only the beginning. As galaxy surveys expanded, astronomers discovered even larger structures. In 2003, researchers announced the Sloan Great Wall, a colossal arrangement of galaxies stretching about 1.4 billion light years across. To understand just how enormous that is, consider this: light, the fastest thing in the universe, traveling at nearly 300,000 kilometers per second, would need 1.4 billion years to cross it. When the Sloan Great Wall was discovered, it became one of the largest known structures in the observable universe. And yet, the universe still had bigger surprises waiting. The more we looked, the larger the structures became. In 2014, astronomers identified the Hercules Corona Borealis Great Wall. This structure is almost beyond imagination. Estimates suggest it spans around 10 billion light years. That's nearly 1/10 the diameter of the observable universe itself. If confirmed as a single coherent structure, it would be among the largest known features ever discovered. Pause for a moment and think about that. The Earth is tiny compared to the solar system. The solar system is tiny compared to the Milky Way. The Milky Way is tiny compared to galaxy clusters. Galaxy clusters are tiny compared to superclusters, and superclusters themselves become microscopic when compared to structures like the Hercules Corona Borealis Great Wall. The scale is so extreme that ordinary human intuition simply breaks down. Yet, these discoveries create a fascinating problem. According to our current understanding of cosmology, the universe should become fairly uniform when viewed on sufficiently large scales. Imagine zooming out from a pointillist painting. Up close, individual dots are visible. From far away, everything blends together. The universe was expected to behave similarly. Beyond a certain distance, matter should appear evenly distributed. But giant walls challenge that assumption. Some of these structures seem so large that they push the limits of what cosmological models predict. Scientists continue debating whether these walls are truly connected structures or whether they only appear connected from our perspective. The answer matters because it could reveal whether our understanding of the universe is complete or whether there are fundamental pieces of the puzzle still missing. To understand how these walls formed, we need to travel back nearly 14 billion years to the aftermath of the Big Bang. In the beginning, the universe was incredibly hot, dense, and surprisingly smooth. But it was not perfectly smooth. Tiny fluctuations existed, minute differences in density scattered throughout space. These imperfections were incredibly small, but gravity amplified them over billions of years. Regions with slightly more matter attracted even more matter. Gradually, these dense areas grew into galaxies and clusters of galaxies. Like rivers flowing toward low ground, matter streamed along gravitational pathways, eventually creating the vast filaments and walls that make up the cosmic web today. Every galaxy, every cluster, every supercluster is the result of those tiny, primordial fluctuations growing over cosmic time. What is truly remarkable is that these ancient patterns are still visible today. The largest structures in the universe are essentially fossils of the Big Bang. They preserve information about conditions that existed when the cosmos was only a fraction of its current age. By studying these walls, astronomers are not just mapping space, they are reading the universe's oldest memories. Now, imagine standing somewhere within one of these gigantic walls. The night sky would be unlike anything we can experience on Earth. Instead of seeing a few thousand visible stars, the heavens might glow with countless galaxies in every direction. Entire galaxy clusters would dominate the sky. Cosmic distances that seem immense to us would become local neighborhoods within a structure spanning billions of light years. And yet, even these colossal walls are not permanent. The universe continues to expand. Galaxies are moving farther apart. Over billions and trillions of years, the cosmic web itself will slowly unravel. Structures that seem eternal today will become increasingly isolated. Distant galaxies will disappear beyond cosmic horizons. Future observers may never know these giant walls existed. They will see only a small fraction of the universe we can observe today. This realization adds a surprising sense of urgency to cosmology. We happen to live during a special era when the largest structures of the universe are still visible. Right now, we can map the cosmic web, measure galaxy distributions, and trace the outlines of these immense walls. Billions of years from now, much of this information may be lost forever. Perhaps the most astonishing fact is that these structures exist at all. Human beings evolved on a tiny planet orbiting an ordinary star in an average galaxy. Yet, somehow, through mathematics, observation, and curiosity, we have discovered structures stretching across billions of light years. We have learned that the universe is not just a collection of galaxies, but a vast, interconnected network of unimaginable scale. The walls of the universe remind us that reality is often stranger than imagination. Every time we think we have reached the largest possible scale, the cosmos reveals something bigger. Every map we create uncovers a larger frontier beyond it, and every discovery raises new questions about how such immense structures came to exist. Somewhere out there, beyond the reach of our current surveys, there may be even larger structures waiting to be discovered. New telescopes are already expanding our view deeper into the cosmos than ever before. The story of the universe's largest walls is far from finished, and perhaps that is what makes this journey so captivating. The universe is not a static picture. It is an unfolding mystery, a cosmic web stretching across the darkness, connecting galaxies, clusters, and superclusters into patterns so vast that they border on the incomprehensible. The next time you look up at the night sky, remember that every star you see is part of a galaxy. Every galaxy is part of a cluster. Every cluster is part of a larger structure. And those structures are woven into enormous walls spanning billions of light years, invisible to our eyes, yet shaping the architecture of the cosmos itself. The walls of the universe are not merely the largest structures we know. They are the closest thing we have to seeing the skeleton of reality, and we are only beginning to understand what they truly mean.